Hello everyone. Recently, while looking for a way to procedurally animate text in Unity, I discovered TextMeshPro supports rich text. Usually, one would use rich text to mark up larger strings of text with a couple tags, but I instead decided to relentlessly mark up each individual character differently every frame to make it look animated. The results came out surprisingly well, and I think it could be a pretty useful tool to make pleasant text animations, at least for those that are more visually inclined. I think this tool would be much more useful in hands other than mine, so without further ado, here is how to make it. This method can be applied to anything that uses TextMeshPro text, so make sure you have that package installed. I'm on version 3.0.6 right now. This webpage documents all the different ways you can mark up TMP text, but I'll just pick a few of them to show you how it works. It's easy enough to add on to it once you have the system in place. For this tutorial, I'm going to set it up with color, alpha, which represents transparency, size, and vertical offset. Before I start building the script, I want to try and explain what I'm building. So the first thing I want to establish is a basic use case. Let's say I'm just using the size tag, and I want to make the text grow from small to large and back to small over 2 seconds. I could set up a parabolic curve representing size, evaluate at each point in the curve, then give that to the size tag each frame. That's simple enough, but what if I want instead to animate the text such that it looks like a magnifying glass is passing over top of the word? In this case, we would want a similar life cycle of animation, but instead of animating the whole word, we'd animate each character with the same animation, but each character is delayed. To do this, we need to get a sub-interpolation factor, where each character gets its own interpolation factor depending on where it is in the string, and I came up with a formula to achieve this. Let's say we have the word hello. This is 5 characters long, so we need to find the start and end points of animation for each of the 5 characters. If we try to visualize this on a timeline, it would look a bit like this. The main line represents the overall interpolation of the whole animation. Each line segment underneath represents the full 0 to 1 animation cycle of each character while moving along the main interpolation. So if we pick any spot on this main timeline representing a single frame, we'd have a corresponding sub-interpolation factor for each character. This is pretty representative of the whole algorithm, so let's figure out how we can turn this into code. First, I'll just make a prefab that is intended to exist in overlay canvas space. So I'll make a new text object which will appear under the canvas layer, and I'll also create an empty game object and use it as a parent to that text object. On the root, I'll add a new script called TextAnimator and open that up. The first thing I need to do is add an inspector variable where we can set the string we want to animate, and I'll just call this message. We also need a reference to the TMP text object. This is an animation we want to trigger at any point in time, and after it's triggered, it needs to update every frame based on how far into the animation it is. With that in mind, we need a function which I'll call evaluateRichText. We can call every frame that receives the position along the timeline during that frame. The fact that we are in an evaluate function with a float variable called t implies that t will likely be a value at or between 0 and 1, representing how far into the duration we are as a percent. In this function, we want to end up with the full string of text populated with each character's rich text markup for that frame. We'll do that by setting the text object to an empty string, then loop through each character in the message we want to animate. Then in each iteration of the loop, add that character to the text object after processing it with rich text tags. I'll do this evaluation in a separate function to separate the units of labor a bit. This is where we do the heavy lifting of the algorithm. The context we are in here is that we are evaluating where in the curve a character is at a given point in time during the animation. To do this, we need to find the start and end point of the animation timeline relative to the overall timeline for this character. We need a few pieces of information for this. Obviously, the character we are evaluating for, but also the overall length of the string, the position of the character within the string, and how far we are into the overall animation. So we have all the parameters that we need, but we're still missing one piece of information here. And that is how long the character animation will last for as a percentage of the overall animation. Since this value can drastically change how the animation looks, we want to be able to tweak it when creating the animation. So I will make this a class variable and expose it to the inspector. I'm also going to give this a range attribute because this value needs to be greater than 0 and no greater than 1. So now we have everything we need to find the start and end points. The formula for finding the start looks like this. We're taking 100% of the animation, or just 1, and subtracting the character animation duration. Then we divide that by the length of string -1, since we index from 0. And finally multiply the result of that by the position of the character. From there, the endpoint is easy enough to calculate. We just take the start point and add the character animation duration to it. I'll break down a couple examples so you can see how this formula is working. Let's say we're still working with the string hello, with a character animation duration of 60%. If we feed in h to the algorithm, the start point will be 0 because its index in the string is 0, and the final step in the formula is multiplying by the index. If we take e though, we get 1 minus 0.6 divided by 4 times 1, which equals 0.1. So the start point of e is 10% through the animation, and will end 70% through it. Similarly, if we take o, we get the start being 0.4 divided by 4 times 4, which sets the start point to 40%, and the endpoint is 100%. This formula works well, because it will always have the start points evenly spaced between each other, and the last character will always end on 100%. With that out of the way, we need to map the current value on the overall timeline to a point within the start and end timeline of this character. There's a well-established formula for this, and I could make another function for this in the class, but I tend to use this formula quite a bit on floats, so this is a handy thing to make into an extension to the float class. I'll just make an extensions class in this file for the sake of example, and add a map method to it like this. If you haven't used extensions before, the this keyword causes this function to become a method of the type of variable you're creating it for. So in this case, whenever I'm working with a float, I can access this method from the dot operator like I can with any other object method relationship. Specifically, what this function will do is take the value you're working with and map it with a given range correspondingly to a different given range. So back in our character function, I want to map the current value of the overall timeline to a new value based on where it is in relation to the start and end points of this character animation. So I can use the map extension like this to get that value. As a quick example, if we have our hello text with 60% character animation duration, and we are 30% through our overall timeline, we know the h starts at 0% and ends at 60%. So when we are evaluating h in that frame, sub t will be 50% because it's halfway through its start and end point. In that same frame, e's start and end point is 10% and 70%, so its sub t will be approximately 33%. We finally have our sub t value, so now we just need to feed in an animation curve evaluation into rich text tags, surround the character with it, and give it back to the original function. I'll start with the size tag. First, expose an animation curve to the inspector, and since I like to keep my animation curves in the context of %, I'll also add a size scale to amplify the values. Back in the character function, I need a start and end tag for size. I'll put these in variables to keep it a bit more readable. If I put a $sign at the beginning of the string, we can add variables easily within curly braces, which also improves readability. In here, we just evaluate the size at sub t and multiply it by the size scale. This tag takes in a %, which represents the size relative to the currently set font. So we need to have the % character before the tag is closed. That's our rich text tag we need for this character, so now we can just return the character surrounded by tags. To test this, we can create a coroutine to run at the start. So I'll make an IE numerator to run the animation. I want to call this at the start, but I want to wait for a couple seconds to let the scene load, so I'll add a wait for seconds parameter to stall the coroutine for that long. Then I need to calculate the % along the duration we're at in each frame. To do that, I need to define a duration in the inspector and keep track of the elapsed time privately. With that, I can call evaluate rich text each frame with the updated t value. I'll then call this in the start function with a small delay to test it out. I'll set up the curve animation duration like I had in the original example and give it a go. You'll also likely want to play with the alignment in the text object. I found justified and baseline were decent options, but you can play with it to see what works for you. Perfect. Now the only problem is I have to restart the scene every time I want to tweak the animation, which is kind of annoying. A better solution can be reached by feeding in a t-value directly through the inspector to test it in the Prefab editor. To do this, I can add a class attribute called execute in edit mode, which will cause the update function to run only when the game is not running. So I can expose an editor t-value in the inspector and limit that range from 0 to 1. Then in the update function, I can just call the evaluate rich text function with the editor t-value. And now if I open the prefab and change this value, we can look at the animation at any step along the timeline. I'll quickly add a few more tags to make it a bit more dynamic. The color gradient is really cool because you can see the progression of blended colors over time and also set the alpha transparency in the same tag. And that's all I have for you now. Hopefully you're satisfied with the outcome, or at the very least have a good idea of how to expand this concept to fit your desires. Thank you very much for watching, and I'll see you next time.